Propose an efficient transformation in the following synthesis. Mechanism is not required. So when we have any synthesis, the first thing we have to do is count our carbons that we have. So just to make sure where we're going. So 1, 2, 3, 4, 5, 6 carbons here, and 1, 2, 3, 4, 5, 6 carbons on the right. So if our carbon numbers are the same, then we are completely fine. We don't have to worry about adding or removing any carbons. So then the other thing we have to see is what kind of functional groups we have. So here we're just starting with an alkane, which is pretty boring. You really can't do much with alkanes. And then here we have a ketone and an aldehyde. So in a ketone and an aldehyde, the only way we have learned how to make ketone and aldehyde in any functional group is via alkenes. Okay, and we did oxidative cleavage, okay, on alkenes. And so oxidative cleavage works in two different ways. You can either use ozone or you can use KMNO4. So in this case, we have to use ozone because our product is an aldehyde. For KMNO4, your product should be an acid. Okay, so once we've decided, okay, we have to do ozonolysis on this, it means that I need to make an alkene. So where does the alkene need to be? Well, the alkene needs to be where the oxygen is. So which means that we need to have a bond between carbon number 2 and carbon number 6, okay, which is perfect because if we look over here, on the reactant side, then carbon number 2 and 6 are actually joined together, okay, which means that that is where we want the double bond to be. So I'm going to write this a little bit in a backward way, okay, so I'm going to go, let me show you how I'm going to go. I'm going to go this way, okay, so that you can see that this is the alkene that we need, okay, in order to do that. But how do we get this alkene? Okay, to get this alkene, you need to have some sort of elimination reaction. In order to eliminate, you need to have some sort of a leaving group. To have some sort of a leaving group, you need to have a leaving group on there, okay? And the best way that we have learned how to put a leaving group on there on an alkane is by free radical mechanism. That's the only thing we have learned so far. So actually you really can't do much with alkanes anyway. All right, so here is that. So you put in your leaving group. So bromine is perfect, and this reaction is going to work really well because this carbon is also a tertiary carbon, which means that's where the bromine will go preferentially. So now I need to figure out my reagents for the rest of the thing. So bromine that I have to eliminate in order to form an alkene, well, I can use any kind of a nice strong base along with heat that will promote elimination. So that will give me the alkene. With alkene, of course, I can do ozonolysis. So I can use ozonolysis, and then for the workup, you need to have dimethyl sulfide, or if you don't want to write that, that's okay. I will accept it, but it's a good idea to know all of these things. Okay, so again, here are your reagents. With an alkane, you're going to do free radical mechanism in order to get the leaving group on there. Then you're going to eliminate the leaving group in order to get the alkene. And once you have the alkene on there, then you will go ahead and do ozonolysis in order to get the product. Okay, so little bit thinking involved here, but eventually we got there.